السلام عليكم ورحمة الله وبركاته والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. So today we'll continue about tahsili chemistry, and I will talk in this video about equilibrium, chemical equilibrium. So what is chemical equilibrium? First, if we have a reaction like A plus B, it will give you C and D. For this is a regular reaction where all the reactant will convert to a product. So if you at the beginning of this reaction, so we have high concentration of the reactant, and if they react, it will convert to products, so their concentration will decrease and the product will start to appear until all the reactant will consumed, so you will have only the product in your reaction container. But this is the reaction, it will be only proceed in one direction, but we could have a reaction that will have two directions like this one. So what will happen in this reaction? At the beginning, we have the high concentration of A and we have zero concentration of B because we don't have any product yet. And by time, the action or the concentration of the reactant will decrease and the product will start to appear until we reach the reaction equilibrium, where the concentration of the A and the B will be constant because we will have two reactions here, not only one. The first reaction where the reaction of A will convert it to B, and the second one where B will convert it to A. That's why when we reach, or this is the point when we reach equilibrium. And so at this point, we have two reactions here. The first one, when A will convert it to B, this will be called forward. And when B will convert it to A, this is called reverse. So we have two reactions, the forward reaction and the reverse reaction. If we have the forward and reverse reaction, so we should have an equilibrium case. But actually, we will not be reaching equilibrium if we have a forward and reverse just like this. We need to have the rate of the forward reaction equal to the rate of the reverse. So we can only reach the equilibrium if we have the rate of the two reactions are equal to each other. And the concentration of A and the concentration of B, which is the product and the reactant, are constant, but they are not equal. So the concentration of A should not be equal to the concentration of B. Sometimes A will be higher or B will be higher, but they are not equal, but they should be constant. If we have the rate of the two reactions are equal and we have the rate or the concentration of the both reactant and the product are constant, so we have an equilibrium case. How to represent the equilibrium? So to represent the equilibrium, we need to write the equilibrium expression constant. This will be called E equilibrium. This will be the constant for the equilibrium. And to write this one, it will be the concentration of the product over the concentration of the reactant. And each one of them will be have an exponent, and this exponent will be the coefficient from the equation. So if you have 2H2 gas plus O2 gas, this will give you 2H2O gas. How to write the equilibrium expression for this one, or the equilibrium constant? So E be equal to the product, and we have the product H2O, and we have coefficient 2, so it will be to the power of 2. And for the reactant, we have two reactants. So the first one will be H to the power of 2 and times O2. And if you have a reaction like 2 or 3H2 gas plus N2 gas, it will give you 2NH3 gas. And again, the equilibrium expression or the equilibrium constant will be the NH3 to the power of 2 over N2 times H2 to the power of 3. And if we see here, we have the phases or the state of reactant and the product, they are all gases. It's very important to check the state for the reactant and the product, because we are not going to write all the state in the equilibrium constant. We can write only gases and aqueous, but solid and liquid will not be written in the equilibrium constant. So if we have CaCO3 solid, it will be converted to CaO solid plus CO2 gas. How to write the equilibrium constant for this one? So it will be equal to product, which is a concentration of CO2 gas, and we are not going to write the other one, which is solid, and over the reactant. If we check the reactant, we will find that the reactant also solid, so we can't write it. So it means that the equilibrium concentration or the equilibrium constant for this one, only the concentration of CO2 gas. So this is the first part. You need to know how to write the equilibrium constant. So if we have an equilibrium or reaction at equilibrium, so it means that the concentration of both reactant and the product are constant, and also the temperature will not be changing, and the pressure also will not be changing, because if you change the pressure or temperature, so it means the equilibrium state will be changed. This will give us or reach with us how to change the equilibrium state. Okay, we need to change the equilibrium, so we will go to check something called Lutahsili principle. Okay, so what is the Lutahsili principle? The Lutahsili principle is principle. It will be studying how to change the equilibrium by changing the concentration or pressure or even temperature. And he stated that when a system experiences a disturbance, this system will respond in a way to decrease or remove this disturbance. So if you try to add substance or an equilibrium reaction or reaction at equilibrium, or try to change the temperature or try to change the pressure, actually the reaction will try again to get the equilibrium state and try again to have equilibrium by its way. So here what we can do here, we can change the equilibrium by adding substance or change the concentration, or so we have four things: change the concentration of a substance, or by change temperature, or by change pressure, or by adding catalyst. Okay, so we'll study each one of them and see how adding or removing any one of them will change the equilibrium. So first, the first one, which is a change in concentration. So if we change the concentration of a reactant or a product, what will happen here? So we have a rule you need to apply. First, if you increase a substance, the reaction will be shifted to the other side. So when you increase in one side, so the reaction will be shifted to the other side. And I will now say what does the shift mean. And if you decrease a substance, so it will be shifted to the same side. So what is the meaning of shift? So if you have A and this reaction A give B. So here, if we have two sides here, we have the right side and we have the left. Sorry, this is the left, sorry. So you have the left side and this is the right side, okay? So, and if we change one of the concentration of A or B, so the reaction will shift it to the right or the left. How to shift it to the right or the left? To shift it to the right or the left, it means that the rate of the forward of the reverse reaction will increase or decrease. So if we want to shift it to the right, it means that the rate of the forward reaction will increase, because this reaction will give us or reach with us to the right side. So in order to shift to the right, so the rate of the forward will increase. And if we want to shift to the left, it means that the rate of the reverse will increase. So if I add more A, so adding more A to this reaction, what will happen if we adding more A to this reaction? So we adding more A to this reaction. So what is the rule said? The rule said if you are adding more substance or increase substance, so it will shift to the other side. It means if we adding more A, so the reaction will shift to the right. So here it will shift to right. How to shift to right? It means that the forward rate is increased. So the rate of the forward will increase, okay? And again, if we increase and the forward reaction, it means the concentration of B will increase because we will produce more B, and again, the concentration of A will decrease because it will try to consume the amount that you added to the reaction. So again, what will happen here if we're adding more A to the reaction? So if we're adding to one side, so it means it will shift to the other side. So the other side it will be the right side. So the reaction or the forward reaction will increase. And if we increase the forward reaction, it means that we'll produce more B. So the concentration of B will increase. Let's continue again with this one with the concentration. So if we have, let's take this one, 2H2 plus O2 will give you 2H2O. So what will happen if we adding more O2 to this reaction? So if we're adding to this side, it means it will shift to the other side. So it will shift to the right. And how to shift to the right? It means that the rate of the forward reaction will increase. And it means that we'll produce more product. So the concentration of H2O is increased. And the concentration of the product of the reactant with H2 and O2 will decrease. And again, we will reach a new equilibrium position. And when we reach this new equilibrium position, actually the equilibrium constant will be the same. Okay, so the equilibrium constant will not change. So what will happen if we remove, not adding? So what will happen if we come to the same reaction, but here what I will do, I will remove O2. So if you remove some substance, so he will shift to the same side when you remove it. So we will remove from the left, so it means that it will shift to the left. So here it will shift to the same side, so it will shift to the left. Okay. If we shift, how to shift to the left? It means that the reverse reaction should increase. So the rate of the reverse should increase or will increase. And if we increase the rate of the reverse, it means that we'll produce more H2 and O2. So the concentration of H2 and O2 will increase. And the concentration of H2O will decrease, because we will produce more H2 and O2, and so we will consume H2O. And again, the rate of the equilibrium constant will not change. It will be the same value. So this will be happening, or what will happen if we add or remove a substance to an equilibrium. So what will happen if we try to change the pressure? Actually, if we talk about pressure, we have two kinds of reaction. Okay, if we want to talk about pressure, so first we need to count the number of moles of reactant and number of moles of product. So if we have like this, A will give you B. So number of moles here will be the coefficient for the substance. So we have 1 mole of A and we have 1 mole of B. It means here number of moles of reactant equal to number of moles of product. So in that case, actually, if you change the pressure, it will not affecting the equilibrium position. So there is no change here. So if you change pressure by adding pressure or by increasing pressure or decreasing pressure, so actually the equilibrium position will not change. And again, if we want to talk about the pressure, it means we can talk about volume for the same thing, because we have an inverse relationship between them. So if we increase pressure, it means that we decrease volume. If we decrease pressure, so it means that we increase volume. So this is the case if we have the same number of moles for the reactant and the product. So what is the case if we have different moles for reactant and the product? So in that case, if we increase pressure, so it will shift to the side with small number of moles. So if you increase, he will go to the small side or the small number. And if you decrease pressure, so it will shift to the side with the high number of moles or large number of moles. So we'll do the opposite. If you increase, you will go to the small number of moles. If you decrease, you will go to the high number of moles. So let's take an example here for this one. If we have the same, I will take the same reaction, H2 plus O2. So we'll give 2H2O. So before we start, we need to count number of moles for both reactant and the product. So here we have 3 moles because we have 2 for hydrogen and 1 for oxygen. And here we have 2 moles. So what will happen for this reaction if we change the pressure? So first, if I increased pressure and increase the pressure, it means that we decrease volume. Okay, so what will happen if we increase pressure or decrease volume? And so again, if we increase, so we will shift to the side with the small number of moles. Which side is the small number of moles? The right side. So it means it will shift to right. And how to shift to right? It means that the forward reaction should increase. The rate of the forward reaction will increase. It means that we'll produce more H2O. So again, the concentration of H2O will increase and the concentration of H2 and O2 will decrease. Okay, so again, we will shift to the right. It means that we need to increase, or the reaction will increase the rate of the forward. It means it will produce more H2O and it will consume more H2 and O2. And again, the equilibrium constant will be the same value. It will not change. So this if we increase the pressure. So what will happen if we decrease pressure for the same reaction? Decrease pressure means that we increase V. So if we decrease, so we will go with the side with high number of moles. So which side? It will be the left side. It will shift to the left. How to shift to the left? It means that the rate of the reverse should be increased. So the rate of the reverse reaction should increase. And to increase, when increase the rate of the reverse reaction, it means that we'll produce more H2 and O2. So the concentration of H2 and O2 will increase. And the concentration of H2O will decrease. And again, the equilibrium constant will be the same and will not change. So this if we change the pressure. Now, what will happen on still? So now we will talk about temperature. What will happen if we change temperature? Actually, we have two kinds of reaction here. We have reactions that exothermic and endothermic. But it's the same strategy here. We will talk about this temperature when we talk about temperature. If you add temperature, so it will shift to the other side, just like the concentration, okay? And if you remove temperature, so it will shift to the same side. But here's the K, or the equilibrium constant, will change. And you need to check the concentration of the product and the reactant. If the concentration of the product will increase, it means the equilibrium constant will increase. If the concentration of the product will decrease, so the equilibrium constant will decrease. Let's take an example here. Like, we'll take the same one, H2 plus O2 energy. So this reaction is exothermic. So what will happen if we increase increase temperature? So I will increase temperature. It means I will deal with the temperature or take a temperature as a substance. So when increase the temperature, it means it will shift to the other side. So increase, it will shift to the other side. Which other side? It will be the left. So it will shift to the left. How to shift to the left? It means that the rate of the reverse should increase. So how to go to the left? Which way or which direction will give you to the left or reach you to left side? So the reverse. So it means that the rate of the reverse should increase. And if we increase the rate of the reverse, it means that we'll produce more H2 and O2. So this concentration will increase. And the concentration of H2O will decrease because we will consume more H2. Here, we need to check equilibrium constant here. If we decrease the concentration of the product, so the equilibrium constant also will decrease. Okay. So what will happen if we remove or decrease temperature? So if we remove or decrease temperature, so what will happen if we in this way? So it will shift to the same side with temperature. So it means it will shift to right. And how to shift to right? It means the forward reaction should increase. The rate of the forward reaction should increase. It means that we'll produce more H2O. So this one will increase. And the concentration of H2 and O2 will decrease. And again, the equilibrium constant will change. And how it will be changing, we need to check the product. If the product increase, so the equilibrium also constant also will increase. And equilibrium constant will be only changing by changing temperature. So the only factor that it will affecting equilibrium constant, it will be the temperature. And it will be the same strategy if you are dealing or taking an endothermic reaction. Okay, so what you need to know another thing before we starting solving problems, something called QSP. So what is the QSP? QSP is called the ionic product. How to write the ionic product? Ionic product is ionic or number of the ions of the substance that will be dissolved in water. Like if we have like BaSO4, this is a solid, it's ionic, but it's slightly soluble in water, so it will not be all soluble in water, complete soluble in water. So when we add a small amount of BaSO4 into H2O, so it will dissociate to Ba and SO4, but actually we will have an equilibrium because not all the ions will be dissolved. So some ions will be dissolved and some ions again will give you the solid. So we have an equilibrium here. If we want to write the equilibrium constant, so it will be the product over reactant, and we know the reactant here is a solid, so it will not be written. So in that case, we will call this one QSB. So if you want to write the equation for the solubility for ionic compound, which is partially soluble, which are partially soluble in water, so you will end by equilibrium, and the concentration of the ions in the solution will be called the ionic product. And the ionic product actually it will be changing from when you're preparing your solution. So it will be changing according to the concentration that you start and the amount of the solid that you started with. That's why QSB it will be, it's not a fixed value, it's a value that is changing with the amount that you started with. So it means it will be measured only experimentally. So you have you will have an experiment and you need to measure the QSB for your experiment. So it will be changing according to your experiment. But what you need to know here is the comparison between KSQ and QSP and K equilibrium. And when you measure the QSP and you need to compare it with the equilibrium constant, this will give you an indicator if you will have a precipitate in your solution or not. And we have three cases here. If we have the QSP is larger than Q equilibrium constant, it means in that case we have a high amount of ions inside the solution, so they will form the precipitate. So you will have a precipitate in your solution. If you have QSP will equal to K equilibrium, actually you will not have precipitate because the amount of the ion is the ion that's only dissolved in water, so you will not find a precipitate formed. If you have QSP less than K equilibrium, also you will not find a precipitate because you have a small amount of ions, so you can add more and form the solution. Okay, now let's start with solving problems. Okay, I will take randomly questions. Okay, reaction with two directions, forward and reverse reaction. So this will be a reversible reaction. So the reversible reaction is a reaction with, it will be B. So reversible reaction is the reaction with two directions, forward and reverse. The rate of the forward and the rate of the reverse are equal. So if we have the rate of the forward and the rate of the reverse are equal, so it means that we have equilibrium. At equilibrium, the rate of the forward and the rate of the reverse should be equal. Okay, let's start with this one. The equilibrium constant for this reaction, we have a reaction here and we want to write the equilibrium constant. So the equilibrium constant will be always the product over the action. So we need to check for H2O to the power of 2 times O2 over H2O2 to the power of 2. So this one is not right. Also, this one is not right. This one is not right. So it will be this one. So it will be the product, which is O2 times H2O2 to the power of 2 or over H2O2 to the power of 2. Calculate the equilibrium constant for this reaction. So here we will have the concentration, but first we need to write the equilibrium expression. So the equilibrium constant, it will be product over reactant. It means it will be the concentration of NO2 over the concentration of N2O4. And you need only to substitute. So for NO2, it's 2 moles, so it will be 2 moles per liters over 1. So it will be 2 over 1, so it will be 2. Okay, sorry, we have here to the power of 2, so it will be 2 to the power of 2, so it will be 4. Okay, if the concentration of reactant is more than the concentration of the product, so the K equilibrium will be, we know that the equilibrium constant is product over reactant. So if the product reactant is more, so it means this one will be less than 1. At equilibrium, the value for the K equilibrium for this reaction is high. If the value for the equilibrium constant is high, it means that you have product more than reactant. Okay, so the concentration of the product are greater. The factors that change the equilibrium constant, we have only one factor that can change the equilibrium constant, which is temperature. Which reaction represents the following constants? So here we have product. So it means that reactant will not, it's not written here. It means that the reactant should be solid or liquid. So we will just looking for or search for the reaction where the reactant will be solid or liquid. This one, that's it. I'm not checking the answer because here the reactant is gas should be written. So it will be this one. Which of the following change the equilibrium? So if we change in pressure and volume, of course, if we change in concentration, of course, and if we change in temperature, of course, so it means it will be all. Increasing temperature for this reaction. So if you increase temperature, it means it will shift to the other side. So the other side here, it will be this side, right? So if you shift to this side, it means the rate of the forward will increase. So you will produce more NO2. So the concentration of NO2 will increase and the concentration of this one will decrease. So here it will be. Increasing temperature for this reaction. Again, if you increase temperature, so it will shift to the other side. So it will shift to the left side. To shift to the left side, it means the rate of the reverse reaction should increase. To increase the rate of the reverse reaction, so you will produce more BCl5 and you will consume more of the product. So it means that will increase BCl5. What will happen if this reaction shifts to the left? So to this reaction shift to left, it means that we need to increase temperature. If we increase temperature, so it means it will shift to left. If an equilibrium is stressed, then the shift, it will shift to, okay, so it will shift to decrease this stress. We can say right or left because we don't have a reaction here, but it will try to reduce or decrease this stress. Okay, equilibrium constant of low solubility product. This will be called what? Okay, of course, it's not low equilibrium. It's not rate of the reaction. It's not Boltzmann constant. It's solubility product constant, which is called KSB. I didn't say this part. I'm sorry. Okay, this one is called KSP, and KSP is called solubility product constant. If reactant and the product are in different physical states, so this reaction is, of course, it will be heterogeneous. So if we have all the reactants and product in the same phase or the physical states, it will be homogeneous. If we have different, so it will be heterogeneous. KSP, which is a solubility product, if we have the KSP is a small value, and again, solubility product is a special case of K equilibrium, and it will be written also by the concentration of the ions like the QSP. So if we have KSP is a small value, it means that the concentration of the ions is very small. So it means that the concentration of the product is very low. Here, which of the following represents the formation of brisket? If we want to form a brisket, it means that the QSP should be higher than KSP or K equilibrium. The common ion effect. So what is the common ion effect? The common ion effect, it will be always decrease the solubility. So the common ion effect will be always decrease the solubility. So what is the common ion effect? Let me say this one. So what is the common ion effect? So the common ion effect, if we have a solution, and inside the solution like NaCl, and to this solution we will add or AgCl, and to this solution I will add NaCl. So they both have the same ions. This ions, which is AgCl, will make the solubility of AgCl decrease because you have AgCl inside your beaker. We have this one is slightly soluble in water, so it will be Ag plus Cl minus, and we have two reactions here, the forward and the reverse. Okay, when you're adding more Cl from NaCl to your solution, it means this concentration of the ion will increase, so it means it will shift it to again to the left. It means the concentration of the Ag will decrease, so the solubility of the AgCl will decrease. So mainly the adding a common ion to a solution will decrease the solubility of the substance.